Lesson 13.1, Task 4. Create and use rules for sequences. How many district handshakes are in a group of 20 people? All right. So the table shows possible handshakes for each person when n equals 2, 3, or 4. People shake hands with each other. For example, person A shakes hands with person B. Person B shakes hands with person A, and so on. So here for two people, you've got AB and BA. So it's two possible scenarios depending on which person started the handshake. So for three people, you've got 2, 4, 6. And for four people, you've got 3, 6, 9, 12. So we got 2, 6, and 12. So it says find a rule for the number of district handshakes in a group of n people. How many possible handshakes are there for a group of 20 people? Look for a pattern. Notice that n equals 2 letter pairs are listed for n equals 3, 6, which is 3 times 2, pairs are listed, and n equals 4, or 12, because 4 times 3 pairs are listed. So those we've already looked at here. So they're just writing that out. They're just evaluating, looking at what they have to see if they can find a pattern. All right, so it says a rule for n greater than or equal to 2 can be, or is written as a subscript n equals n times n minus 1 over 2. All right, so it says in a group of 20 people, there are a subscript 20, and then we're going to plug in 20 for our n values. So it says in a possible group of 20 people, 190 possible handshakes. That's a lot of handshakes. All right, so it says y is n times n minus 1 divided by 2. Select each correct answer. All right, so there are two different letter orders represented each handshake. That is true. We can look at the table here. So it went A, B, and B, A. So you're only going to shake that person's hand one time, not twice, even though the letters could be in reverse. And it says there are two total handshakes. That's only if there's 2 or 3 people there. So otherwise, each district handshake would be counted twice. That's true because of the letters being reversed. People have 2 hands. Well, hopefully people have 2 hands, but that's not going to affect our equation because even though people do have 2 hands, most people only shake hands with 1 hand. So the first and third answers would be your best choices. And that's all for task 4. If you have any questions, let me know. Lesson 13.1, task 5. Use a formula for the sum of a series. While you can find the sum of a short, simple series by adding each term of the sequence it represents, some series have convenient formulas for their sums. All right, the sum of the first n positive integers. So you can see that this is a formula. You may want to write this down. I am going to show you how to use your calculator as well, but this will work if you're summing up a number or something from 1 to a certain number, okay? The sum of squares of the first n positive integers. So again, if you're going to do something squared from 1 to n, this would be the formula that you can use to find that. So it says, suppose a pyramid of golf balls like the one in task 3 is made with 12 layers of balls. How many balls are on the front triangular face? How many balls are there altogether? All right, so identify the sequences, then apply the formula for the series. All right, so the balls in the nth row of the front face, we're going to use this first formula here, okay? So we're going to go from 12 layers. So we're going to go from 1 to 12. And basically what this is doing is this is summing. Remember, it's summing all these numbers from 1 to 12. So 1 plus 2 plus 3 plus 4, etc. This is just giving you a quick formula to use. Also, you can use your calculator as well. So the same thing goes for here. So the total balls in the pyramid from 1 to 12 would be k squared. And again, you can use this formula here for k squared. So all they did was plug in these numbers for the formula, and we can check it using our calculator. So we're going to go to Math, find the summation button here. And then I'm going to go from x equals 1. So the first time we're going from 1 to 12, and we just want to find from 1 to 12 of x, or k, and all it's going to do is sum up those numbers. And it gives us 78, which is what the formula gives you as well. So we're going to go back to math, go to summation again. We're going to go from 1 to 12, but this time we're going to square k, or in our case, x. All right, so this is the formula here, or this is the summation representation, and then here is the formula. And it says that it equals 650 balls. So if we hit enter, we also get 650 balls. So using the calculator is just a shortcut or a way to check yourself if you want to check and make sure you did the formula correctly. All right, so it says, how do you know? How do you know you can apply the formula for the sum of the first n positive integers and for the sum of squares of the first n positive integers to find the sums of the series? All right, match the options that represent the same values. Okay, well, we just checked it with our calculator, so we know it works, but let's see which ones match here. So it says the sum of the terms from a subscript 1 to n. So that's going to be this one. So it's going from 1 to n. And then the sum of terms from a subscript n equals n squared. This is the summation of that. And then it says the addends, okay? So that would be the terms in a sub n of n. So that's going to be, the addends are going to be the terms there. And that means the n squared goes to the k squared here. All right, so that is all for task 5. If you have any questions, let me know.